Today we are going to do section 7.6 on page 748, Gaussian elimination. Now that is not going to be a fun job, okay? But I'm just going to go over the examples, and as long as we learn how to do the examples, there will be no homework, because the process is very tedious, and for the most part, it's just something that we should know how it's done, and that should be good enough for anybody. I mean, it's definitely good enough for me. So let's look at what this means, okay? On page 748, let's look at these. There's a simple 2x2 system of equations here, okay? And then what we're going to write it as, this thing is called an augmented matrix. That's just all the coefficients. That is all the numbers of the system of equations. See, we have the system right there. And this gives you a first idea of what matrices are for, okay? Matrix, among other things, is for this kind of deal. And so anyway, so we have a matrix written like this, and this thing is called the augmented matrix. And then just this part, without what the numbers on the equal sign, just all the coefficients of the variables, that's called the coefficient matrix. Well, because it's the coefficients of all these variables. All right. So then, as an example, then let's look at this system of three equations, three variables. As you notice, some of the variables are missing. Now, when you write it into a matrix form, then the variables that are missing, you have to write 0 for them. And so like this on the following page, okay? So that equation got turned into this. It's still 3 by 3, even though some of the variables are missing, because all the missing ones are called 0. So so then you end up with this is the coefficient matrix, and that's the augmented matrix. What they're called is really not that exciting either, but I guess it's okay. So let's look at example 1. Example 1 on the following page. Then you have a system of equations. Then you write down all the numbers for it, okay, on one side, all the coefficients, and then what it equals to on the other side, and that will be the augmented matrix of this thing. So please do example 1 by yourself, and then and then let's look at example 2. Example 2 is doing the opposite. That is, if you're giving a matrix, then you need to write it back into an equation form. Well, the first one, we'll call it represented by x. The second column, it will be the y's, and the third column will be the z's. And once you substitute all that in, and that's where everything just popped in. Okay, and so please do example 2 yourself as well. And you think, well, this looks pretty easy. Yeah, it's not going to stay this way, I'm afraid. So then, so the next thing what we're going to do is so-called the row echelon form. What that means is we're going to reduce any matrix into this form, where you have a 1 going across the diagonal down, and then zeros under all the ones, okay? On top of ones, you have various whatever numbers. It doesn't matter. It just have numbers. But we need 1 going down and zeros under the 1. And we're going to turn every single matrix into this form. But they are square matrices. That is, they're not. So that's all we care about right now, okay? And then turn it into this. It turned the matrix into this form, the row echelon form. And how are we going to do that? By doing a whole bunch of tedious operations. So let's look at example 3 on page 751. So example 3, we have 2x plus 3y equal to 6, and x minus y is a half, which I wrote it down in the matrix form, 2, 3, 6, and then 1 minus 1 and 1/2. All right, so what are we supposed to do is and we are going to turn this into that form where we need to make it look 1 down the diagonal and 0 down here. So the first thing we're going to do is we have to, well, that there's different process operations that you can do to achieve that. First, the rows can be exchanged if necessary, okay? And because these equations can be exchanged, you know, there's no reason why this is the second equation. We'll just pretend that's the first. So the first thing we'll do is exchange these two things because there's a 1 here, and we want 1s all the way down the diagonal. All right, so I will rewrite this thing. All right, so now I rewrote it. So because remember our goal is have 1 going down the diagonal, okay? It has to be 1, 1, both cases. So anyway, so we got here, and that's the second step. So far, so good. That doesn't sound too bad, except I have done a lot of writing, it seems like, for very little benefit. But anyway, so we got here. The next step we are going to do is that anything that's below the 1 along the diagonal has to be knocked into 0. And we're going to do that by doing multiplying the row with 1 with a negative this number, and then add them together. And in other words, this is called the R1, that is row 1, and this is the row 2. To make this thing into 0, we're going to take row 1, multiply it by minus 2. So row 1 has to be multiplied by minus 2, and then will be added to row 2 plus row 2. Okay, and to do that, then as you can see, this is not particularly difficult or challenging in terms of math, but it sure is tedious. So that's what we're going to do. All right, so row 1 times minus 2 plus row 2. So we're multiplying row 1 by times minus 2. I'll write it here to help us remember it, okay? So 1 times minus 2 plus the row 2, that will be 0. And so this is here. And by the way, I have to write down row 1. This doesn't change. So in this process, so I have to write it down. 1/2 and stuff. Okay, and next, this thing has to be multiplied by minus 2. That gives 2. And then plus 3, that's 5. Next, this thing times minus 2, that becomes minus 1. And plus 6, that's positive 5, right? I better check to make sure I didn't mess up. Because this is, yeah, so far I'm okay. All right, so now we have achieved the goal of having a this is a diagonal. We have a 1 on the diagonal, and then under the diagonal we have 0. That is the goal. And so we have the goal, as I remember, is to have 1s down the diagonal and 0 under all the 1s. Okay, so the next step we need to do is knock this thing into 1, because this is along the diagonal, and we'll do that by multiplying this thing, in fact, by 1/5. Okay, the entire row will be multiplied by 1/5 to make it into 1. So if we do that, then now I have to copy the whole thing again. I'm telling you, I don't like this kind of stuff. This is invented by a mathematician called Gauss. And that's why this thing is called the Gaussian Elimination. And yeah, good for him. I am just not crazy about doing this. Anyway, so to divide by 5, that will make it 1. And then this divide 5 happens to be also 1. So that is, so we have achieved the row echelon form, which is it has to be 1 down the diagonal, and 0 of anything that's under the 1s has to be 0. And being that we only have a 2 by 2, there's only 1 0. If we have a bigger matrix, there'll be more zeros down here. And whatever's up there is fine. So what have we achieved? We have achieved that is that this is x. Okay, we start out with x and y. That's the x coefficient, y coefficient. So what we achieved here is this is y. Y equals to 1 is what we got. So y equals to 1. And then from there, we have, from the first row, we have, so then x, the first row reads x minus y equals to 1/2. And being that y equals to 1, that means x equals to 1 plus and a half, right? Yeah, it's 1.5. So that would be the, that's how, that would be the solution to this system of equations. Now this might look rather tedious, but it is a so-called a brute force method. That is, this is a systematic way that you can solve any systems of equations this way. Okay, it's a guaranteed thing. And you can have the of course, people like me wouldn't want to go through all this, but a calculator or computer can be programmed to do this, and then you just crank it out real fast. So that is that's the benefit of the Gaussian elimination process. And that is this part I want you to learn in this section is know how to do this. Okay, once we know how to do this, we'll move on to something else, because doing this is not exactly the funnest thing in the world. But anyway, that is all right. But first, let me check to see if I got it right. Did I mess up or anything? X equals 3/2. Y is y 1. Where's y? Why am I not seeing y? Yeah, y equals 1. Anyway, yeah, so I'm right. All right, so that's good. And look at that. This is actually a very simple problem. We could have just plugged it in here and cranked it out in no time. But instead, we have to write all this stuff because for the purpose of learning the Gaussian elimination. While it's a bit more tedious a lot of times, it is extremely systematic. Okay, so that is the benefit of this method that we're trying to learn today. So let me erase the board. So next, let's do example 4. And let's see. On page 752, where we have 2x plus y equals to 1, 4x plus 2y equals to 6. And you notice immediately that this is 2x plus y, this is 4x plus 2y. This is just double of this, whereas this is not double of that, which means there is no solution to this thing. Okay, so then because that is not possible, because if 2x plus y is 1, then 4x plus 2y had better be 2. Otherwise, this is not going to, nothing's going to work here. And nevertheless, we're going to apply the Gaussian elimination method and see what comes of it. So let's first, we're going to have to write down the coefficients. So now the first step, I have the coefficients written down. See, 2, 1, 2, 1, 1. I have written here 4, 2, 6, 4, 2, 6. All right, so the Gaussian elimination means that we have to achieve a result where it's 1 down the diagonal by doing multiplication and stuff like that. So the first thing we're going to do is, this is a 2 here, so we'll divide it by 2 to achieve 1. We'll divide by 2 across the board. Okay, so that means we are going to have, we'll divide after that is multiply it by 1/2. That will give us 1, and then 1/2. Okay, and then 1/2. And then the bottom is stays the same. All right, so far we have achieved one thing. Okay, and we have to write the bottom. Well, whatever. So the next step is that we have to reduce everything under the 1 to be knock it into 0. To do that, we're going to take the first row and multiply it by 4 minus 4. Okay, so we'll take the first row, multiply it by minus 4, and then add it to the second row. That should do it, right? 1 times minus 4, add 4, that'll give us 0. So that is what we're going to do. So then we have 1 times minus 4, add to 4, that's 0. 1/2 times minus 4, that's minus 2. Added to 2, that's also 0. And then 1/2 times minus 4 is minus 2 plus 6, that's 4. Okay, and then the first row, we have to copy it down. See, there's a lot of copying, and that's just one of the many things I don't like about doing this. Okay, so now at this point, the book is going to say something, right? And because the second row represent right here, that means 0 equals to 4, because this is the y position, and then or something, and then so this side is 0, okay, and this line means the equal sign means 0 equals to 4, and that's unacceptable, and therefore there's no solution to this example. And yeah, that's example 4. So next, let's look at example 5. Now example 5, we have 3x plus 4y equals to 12 and 6x plus 8y equals to 24. Now that is also not a good system because 3x plus 4y doubles into 6x plus 8y, 12 doubles into 24. Basically these are the same equation. Okay, I mean, so you're not going to be able to, there's no one solution to it. To solve this, the answer given this kind of solution is, well, the way the book wants us to do right now is you just write down, you solve for y from one of the solutions, one of the equations, that's the same equation. So let's say if you solve for y, then we have 4y equals to 12 minus 3x. I'm going by the first equation. And then from there you get y equals to 12 minus 3x over 3. And the book wants you to write the answer like this, where you have something like this, x comma 12 minus 3x over 3 as your answer, because what happens is that any x that you put in, you can choose x to be 1, 0, minus 1, 1,000, doesn't matter. Any x you pick, as long as you plug it in to get the y, that will fit this equation. Yeah, so but anyway, that would be the answer. However, right now we are going to again do that row echelon business, okay? And so let's do that. So let me write down the matrix. So I wrote down the matrix. That is, this is 3, 4, 12. Okay. Now the bottom is 6, 8, 24. All right. So here's our matrix, and we have to again make it down, go down the column, go down diagonally into 1. And to do that, we'll take the first row. We'll work on this one first. First thing, we'll multiply it by 1/3 because across the board, okay? And so if we do that, that will turn into 1. And our entire matrix will become 1, 4/3, and then 12 divided by 3 is 4. And then the bottom stays the same way. And now I have to copy it, 24. And you might think, this doesn't look that bad. Why am I complaining so much? Because this is only a 2 by 2. Wait till you have to do a 3 by 3. Life gets much, much worse. Anyways, but we're doing 2 by 2 right now, so we're okay. And so now we got a 1 here. The second step is we need to knock this thing into a 0. To do that, we'll multiply it by, we'll take row 1, multiply it by minus 6, and then add it to row 2. And that should knock it out, right? Into 0. So the point is anything under 1 has to become 0. And excuse me. So then 1 times minus 6 plus 6, that will be 0. So we're multiplying this row by minus 6, then add it to the second row. And to do that, we have that is 0, okay? And then this thing times minus 6, that would make it minus 8. Plus 8, that's also 0. And then this thing times minus 6 is minus 24, plus 24 is also 0. So we have 3 zeros on the bottom. The top, I have to copy it, 4/3. I'm telling you, this is not the funnest thing to do. Anyway, so now what we get is 0. This line represents the equal sign, okay, right here. So this says 0 equal to 0, which tells us nothing. Right, and that's why this is the solution, because this is so-called having infinite number of solutions, because there is no it doesn't have enough. We don't have enough equations for 2 variables to have a unique solution. We need 2 equations, and this is just a repeat of the first equation. So that's why we got 0 equal to 0 situation here. So then this will be the answer. Okay, you have to. Well, do that and then write down something like that. Anyway, so that's good enough. So that's example 5. Next, let's look at example 6 on page 753, where we have a matrix that we need to turn it into a row echelon form. In other words, we have a random matrix here, right? And we have to add multiply by each row by something, add it to another row until it looks like this. That is, it has 1 down the diagonal and all zeros under the 1s. And to do that, we'll have to do a bunch of, busy work, which there is no getting out of it. So the purpose of doing this is so that you know how it's done. That's it. Okay, so let's go about doing this. First, let me check to make sure I wrote down the right problem. 1 minus 3, 4, 3. 2 minus 5, 6, 6. Minus 3, 3, 4, 6. Okay, that looks okay. So let's do that. Now the book is nice to us that the first one is already 1, so we don't have to do anything there. So that's good. So let's do something. So the next step is we need to knock this guy out. Okay, this guy has to be 0. And to do that, we'll take the first row and multiply it by minus 2. Being that that's a 2, we'll go against it by multiplying by minus 2. And that will apply to the entire row. Everything has to be multiplied by minus 2. And then add it to the second row. Okay, that will knock this thing into 0, right? So let's do that. So the first 1 times minus 2 plus 2, that will be 0. And then minus 3 times minus 2, that's positive 6. Minus 5, that's positive 1. And then 4 times minus 2, minus 8 plus 6, that is minus 2. And then 3 times minus 2, minus 6 plus 6, that is 0. Okay, so I did that. And the rest of it, I have to copy down the rest of all the numbers. Have to be copied, so I'll do that. Actually, I decided not to do so much copying. Let's do it with a little less copying. So we did the second row, that's a 0. Now we'll scratch this out like this, okay? And then we'll knock down the minus 3 by multiplying the first row by the number 3. So let's do it this way. That way I don't have to write so much. All right, so 1 times 3 plus the minus 3, that would be 0. And then the next, minus 3 times 3 is negative 9, plus this 3, that may give it minus 6. And then this 4 times 3 is 12, and plus 4 is 16. And then 3 times 3 is 9, plus 6 is 15. Okay, so at least I got away with a little bit less work. Now at this point, let me check to see if the answer is right. Actually, I'm doing okay. I'm right so far. Okay, so then, here's the second benefit. See, the second number, this position here, okay, down the diagonal, this position here is already 1. We didn't do anything to make it 1. It just lucked out that way. So that's so far so good. And then, so now we just need to knock this thing into a 0. Okay, to do that, I will have to, and how we're going to knock this into 0? We'll use the 1 here. That's what the 1s are for. The 1s, we make things 1 so that we can knock out everything under it into 0. So we're going to multiply the second row by 6, because this is a minus 6. If we multiply it by 6 and add it, then that will kill it. So that's what we're going to do. Okay, now multiply this thing by 6. We'll write the answer here. That's the second row. First, 0 times 6 is 0. We'll have to continue the writing down 0. 1 times 6, that's also added to the 0 is 0. 1 times 6 is 6. And then our result is on the third row, sorry. That is because we're killing this thing, okay? So the result is in the third row. So the first one is the first number is 0. Okay, so 1 times 6, 6 minus 6 is 0. So, and then minus 2 times 6 minus 12 plus 16, that's positive 4. And then, and finally, 0 times 6 is 0. 0 plus 15 is still 15. Okay, so we have the third row, and then the top 2 row looks like that. Now we are going to, and then this is the last, so we have 1 here and 1 here. The last position is now 4, and that needs to change into 1. Now without copying any stuff on top, I'm just gonna do that. To turn this thing into a 1, we're gonna divide it by 4, okay, or multiply it by a quarter. So to do that, then we get 0, 0. 4 divided by 4 becomes 1, and then 15 divided by 4, we'll leave it like that. 15 over 4. And then, so now we can copy down the rest of the stuff, which I will do now. All right, so I am done copying. I copy down the rows from down here identically, I hope. And then, so now we have achieved our goal, which is we need ones all the way down, and then 0 under the ones, and then the rest is whatever it is supposed to be. And that is called the row echelon form. Did I get it right? Let me check. What is the final answer? Minus 3, 4, 3, 1 minus 2, 1, 15 over 4. I got it right. Yay. Well, yeah. As you can see, this problem is actually easy in the sense that we were given a 1 here. Okay, so we didn't have to, if it wasn't a 1, we would divide it by itself. Let's say if it was a 4 or something, then we'll divide the whole row by 4 to knock it back into 1. So that's one more step. And then when we got here, this is a 1 again, which means we didn't have to do anything. If it was any other number, we'll divide it by itself. In fact, divide the whole row by itself, so this thing turns into 1, and everything else happens, whatever happens to them. We don't care. We just divide it, the entire row. And so in this process, we were able to skip 2 steps out of all the stuff. So it's not as bad as it could be. Well, it still is trying my patience doing this type of thing. And then, so that is... Okay, that's example 6. Please do this as part of your homework. Like I said, for this section, I just want you to know how to do this. So if you can do the examples, you can do any of the rest of it. And that's good enough. Just learn. This is called the row echelon form, and know how to reduce any old matrix into this after some patient calculation. So let's look at the next example. So next, let's look at example 7 on page 754, where we have x minus y plus z equals to 8, 2x plus 3y minus z equals to negative 2, 3x minus 2y minus 9z equals to 9. Okay, so then we have, I wrote down the augmented matrix here, and we're going to do that elimination trick where you write down ones down the diagonal and all zeros underneath, okay? And yeah. Anyway, so we have, so I write this down. Let me check to make sure that I got the numbers correct. See, 1 minus 1, 1 and 8. 2, 3 minus 1 and minus 2. 3 minus 2 minus 9 and 9. That looks okay. All right, so then now we have to do that thing. Again, we have a 1 here, so that is a plus, okay? So we don't have to work on it. So, and then we're going to knock this thing down, okay? To knock out this thing into 0, we'll multiply the first row by minus 2. And I will write it down here. So right now we're working on the second row. And I'll write down the first row here, 1 minus 1, and then 1, and then 8. So we're working on the second row. So minus 2 times 1 plus 2, that gives us 0 as expected. Minus 1 times minus 2, that's positive 2 plus 3, that's 5. And then that times that is minus 2. Minus 1, that's minus 3. And then finally, this times that is negative 16. Minus 2, that's minus 18. All right, so we got a 0 here. And so we're supposed to knock this out into 0. Anything under the ones in the diagonal has to be 0. So that has to turn 0 and that has to turn 0. To make this thing turn 0, we are going to multiply the same first row, where 1, by negative 3. Okay, that should kill it. So now we're going to do first row by minus 3 and then add it to this thing. So the first times minus 3 plus 3, that's 0. This times minus 3, that's positive 3. 3 minus 2, that is 1. And then 1 times minus 3 minus 9, that's minus 12. See, we just continue to do this like a good little worker, okay? And then finally, 8 times minus 3 is minus 24. Minus 24 plus 9 is minus 15, I think. Yeah. well, anyway, so that's where I got. Now let me check to see if the book agrees with me. The book wants us to interchange something. Ugh. Anyway, yeah, we're gonna have to do that. Anyway, so that is well, whatever. And well, I'll check later to see if I'm right, because the book interchanged something. Well, because there's a 1 down here, and we're allowed to interchange these things, because these equations, you can interchange them, and there's no reason why it's written like this, right? So all the rows can be interchanged with, and while you're making no difference to the problem. So now I have to rewrite this thing by interchanging these stuff. Okay, so interchanging row 2 and row 3, I'll write it like this. We're interchanging these two things. 1 minus 1, 1, and 8. To do interchanging, the bottom 0, 1, minus 12, and minus 15. That's the third row, now becomes the second row. And then the second row, which is 0, 5, minus 3, minus 18, becomes the third row. All right. So that is that. And now we have 1, 1 here, 0, 0 here. We just need this thing to be 0. 5, that's a 5. Anyway, and to do that, we're going to take the second row and multiply it by negative 5. Okay, that added to the positive 5, that should kill it. We need to make this thing 0. And to do that, we will have let's see. Okay, so the second row is going to be multiplied by minus 5 added to the third. So the first one will be 0, and this times minus 5, then plus 5 is also 0. This times minus 5, that's 60, minus 3, that's 60 minus 3, that's 57. All right, and then finally this thing times that is 75 minus 18. What's 75 minus 18? I don't know. Let's do this. That's 7, 5 or something. That's also 57. All right, that's actually a good sign. Okay, that so now that I did that, now I have to write this. Copy the rest of it down. There's a lot of copying going on. Minus 1, 1, 0, 1, minus 12, and 8, negative 15. All right, now, okay, now I'm going to divide the third row by 57, and simply by just erasing it, because I'm not copying this again. So the third row will be divided by 57, so that's 1 and 1 here. And then we have achieved our result of having 1s down the diagonal, and 1s down the diagonal, 0s underneath the 1s. That's the row echelon form. Okay. So, but what does that mean? That means that the third position is z. Okay, so this represents z equals to 1. And then the second position means that x minus 12 equals to negative 15. 12z, sorry, 12z equals to negative 15. And that z is 1, so that means x equal to 15 plus minus 15 plus 12, x equal to minus 3. Now, I want to check the answer and make sure I got it right before I go any farther. Z equals to 1, x equal to minus, but they have x equal to 4. Did I mess something up? I must have. Let me check to see where I messed up. I see what happened. This is not x, this is y. This is x, right? The first column is x's. The second column is y. Why did I think it's x? This is y. See, this is y minus y. What is that anyway? Oh, minus 12. So y minus 12z equals to negative 15. That's better. So y is minus 3. Yeah, okay. And then eventually, then we have y equals minus 3, and the top one, which says x minus y plus z equal to 8. So where y is minus 3 and z is 1, so it becomes x plus 3 plus 1 equal to 8, that means x equal to 4, right? X is just 4, and that is the correct answer. Yep, 4 minus 3, 1. So after all this struggle, then we the purpose of the reducing stuff to 0 is then we have a 1. We solve the final equation, and then substituting it into the others becomes fairly easy because from each step. Of course, each step also gets more tedious, but at least it's doable. So that is the benefit of the row echelon form. So next, let's do example 8 on page 754. Same thing. We anyway, so we have the problem. Let me check to make sure I got the problem properly. We have minus x minus 2y plus z equals to negative 1, and so I've written down minus 1 minus 2 plus 1 minus 1. Okay, 2x plus 3y equals to 2. So we have 2, 3, 0, z. Remember, if there's missing a variable, you have to write down 0 to take its place. And the first column is x, then y, then z. All right, so then that is 2. And then lastly, y minus 2z equal to 0. And so I have y minus 2z equals to 0. Okay, the first position being 0. All right, so the first thing I want to do is that our goal here is to turn this thing down into a bunch of 1s. Okay, this is minus 1. That's not good enough. We need to, for minus 1, we'll flip the sign by multiplying by minus 1, or just flip the sign. How about we just flip it and forget about that other thing? So we'll change all signs across the board. Okay, everything has to change at the same time. So this becomes 1, 2, minus 1, and then 1. Okay, so everything is changed. And then the second thing we're going to do is, being that there's a 1 here, I'm going to exchange rows like we did before, because there's a 1 here and we need the 1 up here and stuff. So let's copy down this thing on the second row and move this one down to the bottom. So we have 0, 1, minus 2, and then 0. Okay, and then the second row now go on the bottom. 2, 3, 0, 2, 3, 0, 2. So that should be right. And so the next thing we're going to do is we're going to knock this guy out, right? And to do that, we will have the first row has to be multiplied by minus 2. Okay, that should do it. So that will not, and then after we do that, then add it to the third row, and that will knock this into 0. So 1 times minus 2 plus 2 is 0. And 2 times minus 2 minus 4 plus 3, that should be minus 1. This times that is positive 2 plus 0 is positive 2. And that times that is minus 2 plus 2, that's 0. Okay, so far so good. And then, all right, and there's now I have to copy down all the rest of the information. All right, I have everything copied, hopefully correctly, from this row 1 and row 2. So now we have this stuff. So now we have we have 2 zeros here under the 1. We have a 1 here, so that's good. But we need to get rid of this 1 and knock it into 0. And we will achieve that by multiplying multiplying nothing. We'll just add this to this, okay? And that will kill it, right? So then take the second row, multiply by, take the second row, add it to the third row. We will have 0, and then this is also 0, and minus 2, this is also 0, and that's 0. So we got too many zeros. We have 0 and 0. So this will not be 1, being that it's a 0. 0 equal to 0 means that we have a dependent system. That is, there are infinite number of solutions. To solve for the answer for this thing is now we are stuck with, let's see, okay, so the third row becomes that, so all we have is this thing right here. What we're gonna do is use these first two two things to do it. So the first equation is x plus 2y minus 1, minus 1z, I'll write it that way, equals to 1. And the second one is y minus 2z equal to 0. So then what happens then, what we want to do is we want to represent everything in terms of x, okay, to come up with the answer that the book wants. And so everything has to be in terms of x, which means, let me think. All right, so what we're going to do is this will be called equation 1, and that will be called equation 2. And I'll rewrite equation 1 like this. Then we will have, let's see, 2y minus z equals to negative minus x. Okay, I just move x to the other side. And then y minus 2z equals to 0. All right, and now I'll plug it in here. Then we have 2y. So then y equals to 2z, and plug it into this thing, okay? Then 2y becomes 4z. So we write down 4z, being that 2y becomes 4z. 4z minus z equals to negative x. Then 3z equals to x minus x. And then z equals to negative x over 3. And that should be correct. Nope, I'm missing something. Let me check. Yep, I'm missing the 1. See, I said that from equation 1, 2y minus z equals to move x to the other side. What about the 1? I forgot my 1. Plus 1. Okay, so there's a plus 1 here, and z equals to minus x plus 1. That's better. Okay, and then y is equal to 2 times z. So y is equal to this thing. 2 times, copy down what z is in terms of x, divided by 3. So the entire answer, as the book wants it, is you write it in this form. Okay, x, comma, y is equal to 2 times minus x plus 1 divided by 3, and then comma, and then z equals to negative x plus 1 divided by 3. And then you write parentheses. That means any value you pick for x, and you plug it in, and that will give you 3 numbers, right? Once you solve for, once you do the calculations, then those 3 points will satisfy the original 3 equations, because the equations are dependent, which means you can there are infinite number of solutions to it, but all the solutions has to follow this rule. All right. So this is it. We're not going to do the rest of the examples because they are a bit of a waste. The point is that the point of this section is to learn how to reduce things, reduce matrices such that it goes down as 1 all the way down. Okay, if it isn't 1, then you divide it by itself so that it becomes 1. And then do all these tedious operations until you get everything to so that it's down 1, down across, down the diagonal, and 0 all underneath by doing tedious calculations. So we will not do any homework problems in this section. Please simply do examples 1 to 8 by yourself, especially the later examples, by not looking at the answer. Just look at the problem and then try to do this. And once you learn how, once you figure out how to do this, then that's good enough. Okay, let's move on.